Hello, and welcome to today's Saratech Enablement Session. My name is Andrea Hall, and I'm the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Dan Nadeau, who is an Applications Engineer here at Saratech, and he'll be talking to you about Simcenter 3D. Our sessions run about 30 minutes each. They are all recorded and posted to our Saratech YouTube channel, so make sure you check out our past sessions there. Twice a month, we meet right here to learn about tips, tricks, new and old features that'll help you in your everyday tasks. This is an open forum, so if you have any questions or comments during the presentation, just type them into the questions box over on the right-hand side, and I will just interrupt Dan and let him know about your questions there on the spot. Or if you'd like to save your questions until the end, there will be a brief survey as soon as we close out the session. Just let us know how we did today, and then you can also type in any additional questions that you have there, and we'll be happy to follow up with you. And with that, I'm going to pass it over to Dan.
Thank you for the introduction. Hello and welcome. My name is Dan Nadeau, Application Engineer for Saratech. Today, we're going to be going over NX or now called Simcenter 3D. Like Andrea said, I'm an application engineer here for Saratech. My primary focus is FEMAP, NX NX Nastran, and NX CAD. So the agenda today. I'm going to give you a brief overview of the file structure inside Simcenter. I'm going to give you a demo model of a batch clip. Inside that demo model, I'm going to create a mid-surface. I'm going to apply mesh, boundary conditions, and I'm going to go through analysis setup. And the analysis that I'm going to solve is linear statics, multi-step nonlinear 402, and multi-step nonlinear 402 with large displacements toggled on to include those nonlinear effects. So here's just a picture of the model that I'm going to be using. So this is on the right, in the bottom right, it's actually a picture of a physical model that you would receive if you went to NASA Goddard, maybe for a site visit or something like that. They would use this to clip a visitor badge. So one end would go into your shirt or wherever you want, and the other end would hold on to the badge. So this is not the real model. I modeled just a brief mock-up here inside NX just to give a presentation and go over it. Like I said, it's not the real model, so we're not getting real or accurate results, but it's just something to look and make sure that we get the functionality to work correct. Like I said, we're going to have 3 solutions: linear statics, 402, and 402 with large displacements. So I'm not going to have a lot of time to go over some of the 401, 402 information. If you want to reach out to us after the webinar or reach out to me directly, that would be fine. We just have a limited time for this webinar. So solution 401, 402 is the replacement nonlinear solution inside of this Siemens platform here. So that would include our NX CAE and FEMAP softwares. So 401 comes from NX Nastran side, and 402 comes from the SAMCEF side. So a brief overview of the file structure before we get beginning here inside Simcenter. I have a lot of questions that come up related to, how's the file structure and related questions related to it. So on the right, I'm showing the simulation navigator with the simulation file view. And this is very helpful when you're inside of Simcenter trying to figure out why you can't access buttons, where they're available, and things like that. And I'll get into detail coming up in a second. But at the top level, you have your sim part. Below that, you have your fem part. Below that is the I part, and below that is the regular part. So the part comes directly from NX CAD. And then the I part, the fem part, and the sim part are what you are creating in your Simcenter environment. So what is the idealized part? So the idealized part is a local, I'll just say CAE part that you are going to use. Now, why would you create this idealized part? Well, maybe somebody else is working on the same part with you. Well, if you go ahead and you remove a round, a fillet, or you extend something, you delete something, you're actually editing that part. So what we'll do is we'll create an idealized part, which is just an associative copy of it, and we can make any changes that we want, and we don't edit the actual part. So some of the reasons you'll see down here, maybe you're in a managed environment such as Teamcenter, so you don't want to be actually editing somebody else's part, and maybe this is connected to some sort of assembly, and you're just throwing things out. You don't have write access to the master part, maybe you can't even edit it. And what I use this a lot of time for is what if scenarios. Hey, what if I add something, remove something? I want to mid-surface something like in our example. So example at the bottom, you want to preserve those original geometries. And the next part is the sim part. So the sim part contains loads, constraints, boundary conditions, and how we define our analysis. Where the fem part contains mesh, nodes, elements, physical properties, and the material properties. So if you're ever trying to edit something like, we'll just say a load or a constraint, and you're looking at the fem part, you need to step up to the sim part to go ahead and edit. And the same, likewise, if you're going and editing some sort of physical properties and you're looking at the sim part, you probably need to step down to the fem part where you can make those type of changes. So what I'm going to do is hop over into NX, and then I'm going to take that NX model, bring it over into Simcenter, and we're going to go and use this demo model. So what I want to symbolize is somebody taking this part. We're going to symbolize as somebody putting, a finger at the bottom and squeezing down and watching as this part opens as I'm showing in this picture. So here I am inside NX in the modeling environment. I set this up in modeling. You can see my sketch. I can hide it if it's in the way as well. So what we do is we launch the application pre-post, and that would bring us into our Simcenter environment. And it's loading up the Simcenter environment. And you'll notice once we're here, we can create the new fem and sim. And when you select create the new fem and sim, a window will pop open, and it will ask you right away, would you like to create an idealized part? By default, it grabs everything that's visible, but you can select what you want and you can control. And you even have some geometry options. So if you select those geometry options, and maybe I want to include, for example, sketch curves, lines, splines, things that I used for something else, I can also include them inside my idealized part to help drive geometry or make any changes that I need. In this case, I just need this solid piece of geometry. I'm going to grab everything that's visible, and it's going to create the fem, the sim, and the I part automatically for me. And you'll notice down in the left in my simulation file view that all those will be listed. So it went ahead and grabbed it, and it's automatically grabbing a solution. And for my first solution, I'm just going to set up for a linear static solution, and I'm going to accept everything as defaults, because we want to run these solutions to make sure that everything is set up correctly before we go to our next level. And now if we look at our simulation file view, you notice we're at the fem level. So at the fem level, you see we can apply mesh properties and things like that. And we don't have the ability to apply loads and constraints. So anytime that you're trying to find an option and it's not available, you could always use the command finder if you wanted to. Or, remember back to where I mentioned that at the sim level. So if I just double click here at the sim, it'll become the displayed end work part. You'll notice that my tabs change a little bit based on what I'm looking at. And now I have the ability to apply those loads and constraints. So what I want to do is step up to the I part. So once you move to the I part, it's going to yell at me. Before I can modify the geometry, I must first promote or wavelength the geometry. So it's bringing this to the local level, which allows me to edit it by promoting it. So now that it is promoted, I have the ability to edit it at my local level. Now, I want to go ahead and mid-surface this part and get a 2D accurate representation. Now, I'm going to have to apply contact between the top face and the bottom face. So in my instance, I'm going to go ahead and create, I'll just call it a dummy surface at this point. And you'll see why as we go in the analysis. So I'm just going to do a copy face. And I'm just going to go ahead and copy this top tab face. I'm just going to copy it at the same location as it is. And now I'm going to go ahead and mid-surface this part by face pairs. So I'm going to grab the solid body, and I'm going to automatically create. It does a very good job automatically. And I'm going to hide my solid body when I hit OK here. So now that I got a mid-plane, I notice that there's a little bit of overhang in one region, and I want to go ahead and trim that off. So I can go under Geometry Preparation, Trim Sheet, specify the sheet body, and then the object that I want to trim that with. And I can show my result to make sure that I got it what I want. And I notice that that part has been, sliced off as I wanted to. So now I got a nice mid-plane represented of the part. So now this is my idealized part. It's set up differently than the part. I haven't edited the part. If somebody has this in assembly, they don't see my mid-plane. They still see the same part. And say, I'm working in some concurrent environment or with somebody else, and this part is editable. If somebody made a change, you would be able to see my midplane possibly make a change with it, or it would at least flag me and tell me that it couldn't create the mid surface or it had issues. So now that I have my idealized part set up as I want, let's go to the FEM part. So it's bringing me some information. It's telling me that my polygon body has been changed, and that makes sense because I went ahead and mid surfaced it. I'm going to hide my solid geometry, and this is what I'm left with. Now, one thing that I highly recommend doing anytime that you are doing midplane models is to stitch edges. So what stitch edges does is it combines edges together. In this case, I'm doing automatic edge to edge and edge to face. So for instance, this face and this face up at the top share this common edge. And what I'm doing here is I'm combining it so that when I go ahead and mesh it, my nodes and elements are going to line up. Now for this example, I'm going to go ahead and imprint some curves into this top face. And the reason why I'm doing it will make sense further down in the analysis, but I want to separate this into certain regions where I can apply loads and contact in some sort of nice clean fashion. So in this instance, I'm just going to imprint. You specify the curve that you want to imprint. So I'm going to imprint 2 curves and the face that you want those to be imprinted into. And then you need to specify some sort of vector. In my case, it's just a straight vertical vector that I'm defining. And you notice now the surface has been broken up into these 3 regions instead of 1. And I can use that to drive my analysis later. So let's go ahead and mesh this part. So before meshing, I like to create mesh collectors. So in this instance, I'm going to hit mesh collector, and I'm going to do a 2D thin shell. And the first one I'll call the tab. So I want to mesh this little tab part with different properties than the rest. So that has some sort of thickness. In this case, I use 0.01 inches. And this whole part is going to be made out of ABS material. You notice that we have this intricate list of materials by default inside of the Simcenter library. So it has a material and a thickness, and it is referenced to a P-shell property here. So now I have that collector, and let's go ahead and create another collector. And let's just call this the badge. And we're going to do a 2D thin shell as well. And this time, we're going to use ABS material again, but I'm not going to apply a thickness. I'll show you a way that we're going to use our mid-surface to define the thickness for this model. So now I have 2 collectors, and let's go ahead and apply a mesh to the structure. So the first one that I'm going to apply to is the little tab. And I found this 0.04 was a good mesh size for this model. So make sure you put it in the right collector. If you want to change any mesh parameters, you could go ahead and change any of those mesh parameters as well. You'll see that has been meshed. And let's go ahead and mesh the rest. So you can select it, in the window. I can hide this piece of geometry. I can select them over here. I can box select within the window. It's a matter of preference of how you want to select these entities. And these ones, I just want to make sure that they are the other collector that I specified. Now I have the part meshed, and it might make sense for me. I'm just going to go ahead and edit the display of this little tab, and let's just change it to a different mesh color so that we know it stands out for us. And these are just, super small. And the reason why I did that was because, and I'll explain more, is that there is no edge to face contact. There is face-to-face contact. So I sort of, made my solution work by creating this face-to-face contact, which we will be setting up shortly. Now, if I go ahead and plot the thickness of the badge, you'll notice that it has no thickness. And that makes sense because I never gave it thickness in this property. So what I want to do here is let's go ahead and assign some sort of thickness to this part. So I'm just going to right-click on it, edit mesh associated data. And inside here, you have your thickness. So by thickness source property from the physical property, we didn't define that. You could use a field or expression. But in this case, we're going to use that mid-surface that we created, and we can set it a thickness evaluation at every node. And now if we go ahead and plot those thickness and contours again, Now you see that we have those varying thicknesses throughout the structure. And it's not just one simple value here. And you did, I don't know if you remember from the geometry, this part was actually thicker than the rest of the structure. And even if we zoom in pretty good down here, you'll notice that we do have a gradual, taper, because, this is how the part has been set up as well. And, the tip of those entities are, the thinnest portion in the model, which makes sense based on how the geometry was. Okay, so now that we have the part meshed, we have everything that we needed at the FEM level. We can go ahead and step up to the SIM level where we're going to apply our loads, our constraints, and our contact. So at this level, let's go ahead and apply a load. And in this case, we're going to apply a pressure. And now you notice that I have this simple little location. So this is why I imprinted over here, because I can say at this location, somebody's pushing down, and I'm just using a pressure of 50 psi in this case. And I'm going to use a user-defined constraint, and I'm going to fix the bottom, assuming that the bottom of the person's hand that's holding it is holding it firm. I'm going to go ahead and say all fixed. And now we have our simple boundary conditions defined. So let's go ahead and set up contact. We can right-click on our simulation object. You can always do it from the pull-down as well. And here you see there's surface-to-surface contact, and then there's edge-to-edge contact. There was no edge-to-surface contact, so that's why we created that tab. So surface-to-surface contact. You can do it automatically, and you can select this. I like to do this manually, especially since my model is pretty simple. I only have 2 places that are going to be in contact. I'm going to define my source region. In this case, I'm going to define this as this tab. You'll notice I can't select it. I can select elements, but I don't have my geometry turned on, and that's why I'm having that little issue of selecting that based on geometry. So now that I toggle that back on, it's easily selectable based on that geometry. And the reason why it's nice to pick geometry is if maybe the mesh update, my selection here will remain the same because those meshes are associated to this piece of geometry.
Hey, Dan, we actually have a question.
Yes.
So David would like to know if you could point out any features, such as that thickness to mesh correlation feature, that don't exist in FEMAP.
So that sort of does exist in FEMAP. There is under modify, update elements, adjust mid-surface thickness and offset, which will be able to grab information from a mid-surface and map it to elements. And if you want, after the webinar, I can go ahead and show you. I have a nice example on that as well.
Are there any other features, though?
One of the major features here inside Simcenter is that maybe I come up with my design and it's perfect, and I just want to do a simple change. Maybe I want to stretch out the length of, I'll just say, the jaw engine here. I can just drag and pull the geometry in the mesh and everything will update. Where FEMAP, you would have to, you would have to do a lot more work. This one, I just pull, I can edit the geometry and have the mesh update on the fly. That is one of the biggest differences between FEMAP and Simcenter.
Okay.
And if you have some more questions, feel free to reach out to me afterwards and we can go over some of these as well. Okay, so now that I have one region defined, let's go ahead and define the other region that's in contact. So this is going to be my target. And here I'm going to specify these two top surfaces. So I'm saying this tab is going to slide across in this. And the reason why I broke it here is, well, I don't want it to be in contact if it goes out here. I'm already too far in my analysis anyway. And it just decreases, solution time by not including more things that could be in contact. Now, for this case, I'm going to select the bottom since it's going to be the bottom of the element normals. And we can view element normals under checks and information if we wanted to as well. So now I have these two regions in contact, and now I'm going to define a max search distance. In this instance, I'm going to point 0.1 inches, and I'll show you why I specified this when we get to the next step in our solution. Now, there are these local contact parameters, but the first one is for 401, the second one is 601, and the third one is 402. So in this instance, we're going to run a linear static solution, and we don't need to worry about them. So now we have contact pair between them. It stands out pretty good. Let's go ahead and edit that display. Let's make it a little bit smaller so it doesn't take up. There we go. So now we're saying that this top face can be in contact with this one, and it allows it to not go through it, and it can slide across. So now that we have our simple linear static solution set up, let's go ahead and solve it and get some results. In our solution, make sure that we have contact, we have our constraint, and we have our load. Good. Go ahead and solve it. And this should take a minute or so. One important thing, if you are using contact, I highly recommend looking at the FO6 file. I know I'm not pulling up the FO6, but I'm just looking at this information, and it's telling me right away that contact has happened. Now, one thing that I want to do, which I guess I forgot, which will help us here, is under our solution, let's go ahead and edit our output request, and let's output request contact. So under contact results, we can enable contact results. So then we can plot and I can show you as well that contact has occurred. So both these are very important if you are using contact. Look at that FO6 file. Make sure that it says contact has actually happened. As if you applied contact and nothing, it didn't seem to happen. Well, just double check and make sure that, contact was occurring. You can define it and contact can't, might not happen. So just, it's a nice little check to make sure that is occurring. So now we have our results. We can look at displacement. In this case, we want to know, hey, does it open? Did it work? So in this case, yes, it looks like it worked. But one of the problems with running a linear static solution with contact is you can see I have contact force, and it only occurred at the start. So it's not like dragging and moving along in time. So that's where we want to use 402 with large displacements, actually. We want these things to move. But what I like to do anytime I'm doing nonlinear analysis, hey, let's get it to work in a linear realm first before I go ahead and step up to, including large displacements and including material nonlinearity or geometry nonlinearity. So that's where we're going to go next. Is let's go ahead and make sure that we can get 402 to work before we turn on large displacements. So 402 is, like I said, the new multi-step nonlinear solution from Siemens. And 402 was, I guess, developed or started based on the Simcenter software. So here we're going to go ahead and create a new solution. And this solution is going to be 402, multi-step nonlinear kinematics. So I'm going to keep all the defaults right now. And you'll notice that since it is multi-step, you can specify multiple steps in the subcases. So you can do nonlinear statics, dynamics, preload. So something you could do is you could preload something and then run, normal modes, or you could preload something and then run statics. So you have all these options, and that's one of the big benefits here of running a multi-step solution. So this instance, we're just going to do nonlinear statics. We just want to make sure everything's running smoothly before we go. We're going to specify, hey, we want 10 increments. Make sure that, we cut down the solution into 10 little time steps. Now, just like before, I want to make sure that I have on my output request for contact. Let's just make sure that I have contact working, and there, it's good. Just want to make sure everything's good to go before we continue. So we have our nonlinear static subcase, and inside here, let's go ahead and apply and grab a load, and let's drag our constraint down to this new solution. I guess I'll rename it so it's easier to see. Let's call this 402. So now I drug my constraint down. I'm not going to do a temperature, so let's remove that. So I drag my constraint in. Let's drag the load in. And I want to define a little bit different here in our contact. So I'm just going to clone what we have here. And let's go ahead and rename this, and we'll just type 402. So I'm going to use this for my 402 solution. I still want to use this max search distance. And now I want to define some contact parameters here for multi-step kinematics, create a modeling object, and I'll call this one 402 so I don't get confused. And inside here, I need to apply the default offset parameter here. So in this instance, it's 0.048. This value is half of both thicknesses combined. So that's why when I said I want search distance of 0.1, well, that's if I multiply this by 2, I get approximately 0.1. And that's why I'm using that in the parameter before. So now I'm including the shell thicknesses is what I'm doing here. So now I have contact for that. I'm going to drag it in, and now I have this solution set up with contact, my load, my constraint. Let's go ahead and solve it. Now, this one, we can go ahead and select this 402 tab. You'll see it run through. We can go ahead and plot a simple convergence graph of the iterations. And you notice it's going through. It goes through my time step, and I broke it down into 10 time steps. And you'll see it go through the solution at 0.1, 0.2, all the way up to 0.10. Well, I guess 1 through my solution here. And it's going through my time steps. And this, I don't have anything crazy nonlinear. I didn't even toggle the nonlinear. So it's working nice and smooth. So let's go ahead and look at our results. So this is just a test run. Can we get this to work as we expect? And now you'll notice that I do get 10 increments. And just like before, we can look at our displacements. We can animate now that we have a bunch of iterations. It might make sense to go from the beginning to the end. And we can animate as this thing slides and opens. Now, one of the things here is, since we didn't toggle on large displacement or anything, we're not including any nonlinear, abilities, informations. So contact force, you notice at time step 1, it's still contact at the beginning. So if we want to include that, contact sliding across, we need to induce the nonlinearity. So let's go ahead and clone this solution and set it up with large displacements. So I'm just going to go ahead, rename this LRG 402. Now, in this one, I'm going to delete the subcase, and I'm going to create a new subcase. And the reason why I'm doing this is because instead of using nonlinear statics, I want to use nonlinear dynamics. I want to use some of the inertial information that's going on across here. And this time, I'm going to specify 100 increments, give it more time to converge. Because you notice as this thing's going to be sliding along, it's going to be causing more and more iterations. It's going to have to update the stiffness matrix more and more. So updating this to a higher increments is definitely going to help us here. So now that I have this new subcase, we would need to create our, grab our load, put it in here. And just like before, we're going to go ahead and create another one of these simulation objects. So I'll clone it. I like cloning, it makes it easier for me to go in here. And I can call this large 402. And for the multi-step, I want to define some new kinematics. So I'm going to create a new modeling object, and I can define this. And I'll do this 402 large displacement. And for here, I'm going to enter in that offset value just like before, 0.048. And this time, my displacement formulation is going to be large displacement. So this is large displacement for contact. So we'll toggle on, and contact will work in a large displacement formulation. And then for the solution, I would also want to toggle on large displacement parameters. There we go. So toggle on here large displacements if I want to include those large displacements in this analysis. Now, I'd go ahead and solve this, but it took me, 25 minutes to solve. So we'll just do this little trick and pull it out of the oven here, completed. So now I went ahead and solved that model. And you'll notice here it is on the left. I have my nonlinear statics up here. And then down here, I have my 402 simple model. So you'll see that we get different models when we include this nonlinearity. And the one important thing that I want to show here is with this model is if I look at my results and we just look at, we'll just plot something like contact force and we just, animate, I guess it doesn't make contact yet, throughout the whole iterations. I don't know how well this will go through, but we can try from the beginning to the end. And you can see it moves and it's showing you the contact is moving as it's running through this solution. So I'm not sure how clean it's going across the internet, but it is cycling through the steps and the contact is moving along. So now we induced nonlinearity to the model, and we changed the contact parameters as we went through it using the solution 402 to set this up. So related to that question that was earlier, so one of the big things now is maybe you wanted to make some sort of change to the model. You could always go back to the I part, make a change, or if somebody came into the original part and maybe made some sort of change, I'll just do something simple, and they, I know this is simple, it's just a property to change, but maybe they made some sort of change, like that. You could just go back to your fem part. In this case, it doesn't look like much change, but if we go back to the fem part, it's telling us, hey, something has changed, and you have the ability to update it here on the fly. And that's one of the big beneficiaries to go ahead and use a software like Simcenter. So I hope I went through, showed you guys a lot of information using the simulation file view to go from your sim part to your fem part to your idealized part to your regular part. Understanding this simple simulation setup will help a lot inside Simcenter and with your analysis, if you will. All right. So I gave you that, basic overview of the file structure. Didn't get too deep. I showed you guys a little bit about 402, setting up analysis. I showed you going through mid-surfacing, meshing, and the boundary conditions of this demo model. So if you guys have any further questions, feel free to reach out. I know we only have so much time. Thank you very much.
Great job. Thanks so much, Dan. I don't think I see any other questions that have come through. So again, if you have questions that you didn't get to ask or comments that you'd like to make, once we end this session, you can go ahead and leave those in the quick little survey that we have afterwards. And with that, I just want to let everyone know that we will be posting this to our YouTube channel later today. Feel free to pass it along to your friends and colleagues. Make sure that you subscribe to our YouTube channel, follow us on Twitter, LinkedIn, all of the above, and you can find out about all of our other webinars that we have. And like I said, don't forget to stick around for about 30 seconds afterwards. We just have a quick survey. Let us know how we did today, and also give us suggestions for future sessions. We don't go too deep in these sessions, but some of them are very specific. So there may be something that you're wanting to hear about. Just let us know, and we will see if we can make some videos for those. And thank you all so much for attending, and we hope you have a wonderful day.